What is a relational database? Relational database maintain data in table, providing an efficient, intuitive, and flexible way to store and access structured information. Tables, also known as relation, consist of columns containing one or more data category, and rows, also known as a table records containing a set of data defined by category. Application access data by specifying queries which use operations such as project to identify attributes, select to identify top, top, toughest, and join combine relation. The relational model for database management was developed by IBM computer scientist Edgar F. Code in 1970. Give an example diagram of a relational database. For example, let's say we have two tables, student and courses. The student table might have column for student ID, name, name and age with student ID as the primary key. The courses table might have column for course ID, course name, and student ID, foreign key, where student ID related to the student who is enrolled in that course. How do relational database work? Relational database provide an environment from which data can be accessed or reassembled in a variety of different ways without needing a reorganize the database table. Each table has a unique identifier or primary key which identities from the information in the table, and each row contains a unique instance of data for the categories defined by the columns. For instance, the table might have a primary key of the first name and rows with specific examples such as John, Paul, George, and Ringo. The logical connection between different tables can then be established with the use of foreign keys. A field in the table connects to primary key data to another table. Relational database management system often employ SQL or structured query language for gathering data for report and for interactive queries. So in our example, first name might be linked to a row tables with the data rows of vocals, bass, guitar, drums, and lead guitar. Give two example. Give important aspect of relational database. Since the invention of computer, managing and storing data on machine has been an ongoing field of the research. Before relational database, organization used a hierarchical hierarchy hierarchical database system similar to folders on your computer. This early database system could organize large volume of data. However, they were limited in how you could uncover data relationships. They were also complex, proprietary, or particular application and requires technical expertise to work with. The relational database model emerged as a solution to this problem. It separates physical data storage from database management and usage. Modern relational database let users store and retrieve data without having to manage physical data storage. You can also manipulate logical data structured programmatically. What is data warehouse? A data warehouse is a data management system that stores large amount of data for later use in processing and analysis. You can think of it as a large warehouse where truck unloaded their data. That data is then sorted into rows and rows of well-organized shelves that makes it easy to find exactly what you're looking for later. What database warehousing? Why is data warehousing important? Data warehousing is an increasingly important business intelligence tool, allowing organizations to ensure consistency. Data warehouses are programmed to apply a uniform format to all collected data, which makes it easier for corporate maker to analyze and share data insight with their colleagues around the globe. Make better business decisions. Success business leaders develop data-driven strategies and rarely make decisions without consulting the facts. Data warehouse improve the speed and efficiency of accessing different data sets and make it easier for corporate decision makers to derive insight that will guide to business and marketing strategies that set them apart from their competitors. Improve their bottom line. Data warehouse platform allows business leaders to quick access their organization's historical activities and evaluate initiatives that have been successful or unsuccessful in the past. This allows executives to see where they can adjust their strategy to decrease costs, maximize efficiency, and increase sales to improve their bottom line. Benefits of data warehouse. Data warehouse provides better analysis. The benefits of data warehouse. Beyond wanting to meet their goals, business also want to beat their competition. To accomplish this, ultimately you need to make better business decisions that your competitors. A data warehouse can facilitate this win. Once a data warehouse is integrated into your data strategy, the positive impact will will be immediate, since a data warehouse is solving ongoing problem or combining data from this disparate data source and blending it together in one centralized location. You can then convert the data into actionable information. The immediate and long-term benefits of data warehouse include separation from operational system specifically designed to analyze data. Cost-effective. Even though you're investing a new system, data warehouse offer moderate pricing for long-term data storage. Available of queries. Because you don't have to run queries on your operational database, data warehouse are solely available for queries associated with the defined period of time. Since it's so cost effective to store data on data warehouse, you can keep historical information intact and organized, static, or non-volatile system that is a typically read only and append only. These are all benefits in investing in a data warehouse, because it allows you to perform analysis on company data and allows your company to have access to insight in a reliable and fast manner. Data warehouse provide better analysis. Let's recap what we've learned so far about this data warehouse. Unlike a database which is focused on user inputting data, a data warehouse is architected for decision making, ad hoc queries, and analytics. Those enable queries to be performed without any impact to your company operation database. Additionally, data warehouse are made to store large volume of historical data, often spanning a few years back, while still being able to quick query data. Understanding what the types of the analysis can be performed on your data warehouse is crucial in using the analytical system to its full potential. A data warehouse can be performed the following: enhance business intelligence. In combining data from multiple data sources, your analysis will be benefits getting a complete view, whether it's marketing conversions or product usage. Data quality and consistency. Everyone in the company will get data from one source, providing a single source of truth, which accelerate decision making, improve across the organization. Track, manage, and improve performance at the company and move granular departmental level. Better decision making. No one has to make business decision based on incomplete or limited data or worse institution alone. Decision maker will be able to view dashboard in real time and make decision based on data. Access to data. With faster access to data, your company will be able to make decision ahead of the competition. Because data warehouse are designed to perform analysis, they enable users to ask questions and iterate on result. Refining a product, sales, a process, and or marketing campaign is beneficial to competitive companies. And so, if analysis performed on the data warehouse can provide intel into that, it's no brainer or segment your data system to a database and that data warehouse. So, how to use data warehouse in business intelligence? Business intelligence, as we know today, will not be possible without a data warehouse. At its core, business intelligence is the ability to answer complex questions about your data and use those answers to make informed business decisions. In order to do this well, you need data warehouse which not only provides a safety way to centralize and store all your data but also a method to quick find the answer you need when you need them. Companies use warehouse to manage transactions, understand their data, and keep all organized in short. Data warehouse make large amount of information more usable for organization of all sizes and types. This has made the Lynchip of data pipelines and business intelligence system the world over and understand how data warehouse work can help you fulfill the full potential of business intelligence. What's the role of data warehouse in business intelligence? The business intelligence data warehouse serves as the backbone of data storage. Business intelligence relies on complex queries and comparing multiple sets of data to inform everything from the everyday decision to organization with shift and focus. To facilitate this business intelligence is comprised of three overarching activities: data wrangling, data storage, and data analysis. Data wrangling is usually facilitated by extract, transport, load, ETL technologies, which well explained in detail below. And data analysis is done using business intelligence tools like Chartio. The glue holding this process together is the data warehouse, which shall serve as the facilitator of data storage using OLAP. They integrate, summarize, and transform data, making it easier to analyze. Even though the data warehouse serves as the backbone of data storage, there are not only technology involved in the data storage. Many companies go through a data storage hierarchy before reaching the point of where they absolutely need a data warehouse. Assessment. Which data warehouse and business intelligence system architecture and OLTP versus OLAP in YouTube. Business intelligence can be used to improve operational efficiency by tracking, reporting the our KPI on the product, profitability, analyzing the risk in our operation, and we did mention how to produce a lot of KPI for a balanced scorecard. On the customer side, we use business chargers quiet a bit to conduct sales analysis, sales forecast, segmentation of the market, try to come up with the cross-selling product, applied analytics to the CRM database, and analyzing our marketing campaign and analyzing profitability across various customer segmentation. So we do ask a lot of what and why question, or even how some belong to the online transaction processing application like the traditional database, but some belong to the data warehouse and business intelligence related to the application. If you ask question about the specific or specific product item, specific customer in terms of product inventory level for a specific product, on the status of the customer order and customer payment record and etc. That's one transaction processing system area. Furthermore, in aggregated, summarized, deeper analytics related question belong to the data warehouse. And business intelligence, for instance, what factor affected order processing time and how did there is a product line or category contribute to the profit last quarter, and which product has the lowest gross margin, etc. That belongs to the business intelligence arena. This diagram showed as the architecture for data warehouse and business intelligence and kind of the process, how the raw data migrate to the warehouse, eventually be used by the end user for analytical purposes. Step 1. Over here is the diagram is the source data source. We have multiple sources for the data. It could be in the traditional transaction processing system. It could be flat file and Excel workbook can be source for the data, which need to be integrated and consolidated and put into the specialized database, which we call data warehouse. So data warehouse conceptually is still a database, but sometimes we do use the specialized database technology to handle data stored in the so-called data warehouse. Get the data into the data warehouse from its multiple sources required a lot of effort, and the process it is called ETL, extract, transform, and low you extract data from multiple source. You will perform some kind of transportation to clean up the data, converting, for instance, currency to a standard currency such as a dollar, and eventually in batch mode we will load the data into the data warehouse. So data warehouse is enterprise wide in nature, but sometimes, let's say, the finance department or the registrar office, like in our university, need to look enrollment data, need to look student payment. We may actually create a subset of data from your data warehouse into something called data mart. So think about data mode is just like a subset of the data warehouse, and we still use kind of ETL tool, extract, transforming, loading tool, to create this data mart. And from the data mart from the data warehouse, we can create something called the data cube, online analytical processing cube. The cube is kind of conceptually multiple dimensional data set that's derived from the data warehouse and which ready to be used by the front end tool. The front end tool includes simple query tool, reporting tool, analytical analysis tool, or even data mining tool. And if you remember, when we talk about Excel, we mentioned pivot table as example of an analytical tool used building into Excel. We can extract data from the data warehouse into Excel pivot table, which allows us to analyze it in multiple dimensional way. So this architecture gives you a kind of architecture give you a kind of overview of what constitutes of the environment, the software, hardware, and environment for data warehouse and business intelligence application. The reason we want to build a data warehouse for a business intelligence application is that one online transaction that should be online transaction processing the online transaction processing application database are usually fully normalized database. Normalization is one of the technique in the database design is particularly applicable for online transaction processing application database. When you normalize a database, you usually use to have much smarter table. For instance, instead of grouping order into single table, we have order and order details instead. Combining category data in the product, we have category table which is separate from the product, and this will allow us to process transactions very efficiently. If you're changing, say, the product pricing, there is only one place in the product table which you need to worry about. However, when we try to use a fully normalized database, a lot of the time for reporting for purpose for data. For analytical purpose, a lot of try to use the fully normalized database. A lot of time reporting purposes for data for analytical purpose a lot of time. We need that to join multiple tables, which can be a very expensive and slow process in one or of our assignment. For database, for instance, as you to come up with the total sales annual sales or for each of the product, you actually need to go through order details and order table and encode and join that with the product table in order to get all the information about. For instance, order day, you probably need that you need the unit price, you need the quality, and you probably need the product name in order to come up with the on the query result. So that the minimum in this case, we're joining three tables together. And if you have like 1,000 product, you may have 100,000 order details in the year, and then the query can be very expensive, which will slow you down in terms of your operational side of transaction. In transaction processing system, people who place an order expect to get kind of confirmation for their order to go through. In processing system, people who place an order expect to get kind of confirmation for their order to go through in probably 2 seconds, no more than 2 seconds. But if you conduct such an expensive query like the one we just mentioned, you may slow things down dramatically, and that's one reason we want to move the data from this normalized database design. So to some extent, a normalized and aggregate specialized database called the data warehouse, and once we denormalize it, actually the data will be kind of aggregate combined together, which make it very easy for the end user to understand what in there. Later I'll show. So example of a single design of a data warehouse, and then you understand the simplicity of the data model of the data warehouse. In this slide, we can have a table compared the difference between online transaction processing system and online analytical processing system. An online transaction processing system is basically for handling business transaction and recording data generate their business event, and on analytical process. Business system basically rely on data warehouse and some of the data analysis tool to generate business intelligence. Let's look at one attribute at a time. The source data come from operational data for OLTP and for all of data warehouse. It's consolidate data, and data come from variety of OLTP database. The purpose of data for transaction processing system is to run and control fundamental business tasks, and for data warehouse to help with the planning, problem solving, and decision support. In the data in transaction processing system, review a snapshot of ongoing business activity or process. And for data warehouse, it's multi-dimensional view of different kind of business activity. And for insert update on transaction processing system, we do handle the insert data, update, and delete of the data we have in the database, and usually they are initiated by end user for data warehouse. We rely on long-running batch job to refresh the data we have in the data warehouse on query. Typically, query for transaction processing system are simply and usually they return relatively few records. Query against data warehouse often and quite complex and involves a lot joins operation and aggregation. Applying aggregation function in the query processing speed for operational system need to be a really fast. I would say the response time probably respect sometimes to be less than 2 seconds for data warehouse operation. It depends on the volume of the data involved. It tends to slower, particularly for the data refresh and how for complex query. And however, it's possible we can speed up the query by creating indexes. On the some frequently used column, we can do the same thing for operational system. By the way, in terms of creating indexes, space requirements operation system, since the data size is relatively small to space requirements is relatively small for data warehouse. The amount of data are quite large, size size of the data in the data warehouse tends to be much bigger for the data design transaction processing system. Database tends to be highly normalized, much smaller database table, and many more table for data warehouse. We have kind of the normalized table, which are fewer, and usually they are in the shape of so-called, we call the star schema or snowflake schema, which is reflecting the structure of the data warehouse. Design backup recovery, we do need to take care of with backup recovery of operational data. Operational transaction processing system, because you cannot afford to kind of lose data. And for data warehouse, you can certainly do regular backup, but also a lot of data can be created through the online transaction processing system. Summarize what you learned to the video. Professor Minder Chem from CSU Channel Island talks about data warehousing and business intelligence. Business strategies can be used to improve operational efficiency by tracking and reporting KPIs, analyzing risk, and conducting sales analysis. Online transaction processing system handles specific real-time data, while the data warehouse and business intelligence deals with aggregate deeper analysis data. Warehouse architecture involves extracting, transforming, and loading data from multiple sources into a specialized data. Data marts are subsets of data warehouse of specific departments or purposes. Data cube are multi-dimensional data sets derived from the data warehouse for analytical purposes. Fully normalized database are efficient for online transaction processing but slow for reporting and analysis data warehouse. The normalized and aggregate data for easier analysis and reporting. Online transaction processing system focus on recording business transaction, while the online analytical processing system are relied on data warehouse for decision support. data warehouse requires more space and processing time compared to online transaction processing system for complex queries and data refreshment.